Hi everyone, welcome to this webinar on smart phenotyping. It's a pleasure to see so many attendees today from all over the world. I'm Romain Royer, Marketing Officer at Dorian, and I'm glad to present you today 3 experts in phenotyping data. So here is Keren Moshelian, CEO of Ditech from Yavne, Israel. Hi Keren.
It is wonderful to be here, and thank you all for joining us today.
And we are also with Lee West, agronomist and business development lead at Hiphen from Virginia, USA. So what's up, Lee?
Good morning, Americas. Good afternoon to Europe and Africa, and good evening to all of our friends and colleagues in Asia. Welcome to this webinar. Look forward to talking to you shortly.
And finally, please welcome Tristan Duminil, agronomist and business manager at Dorian, with me today in Nice.
Hi everyone, thank you all for joining us, and I'm pleased to share a moment virtually with you. Hi.
So today we'll learn more on those smart phenotyping tools that collect information on environmental conditions and plant phenotype. You will discover what useful information bring smart phenotyping tools and how it can accelerate your plant breeding program. Many activities and skills are involved in plant breeding all along its long process: agronomy, biochemistry, biology, biotech. And at the heart of your research department lies the information system, which is a secure database centralizing all the information you need to take decisions in your daily operations. And Tristan from Dorian will tell us more about this and its integration to all the other activities. And today we'll have also a special highlight on biology that studies GBI interactions and vegetal physiology at the plant level with Keren from Ditech to study new traits that save time at every stage of the selection. And some use cases as well in agronomy. This is the expertise of Lee from Hiphen, who will present innovative ways to scan the fields from above and get insightful information from the analysis of these images. You will see how these new phenotyping tools bring new information that enhance and accelerate decision-making at every stage of the breeding program. From pre-breeding with the initial screening of progenies, ecotypes characterization, and the setup of breeding objectives, to breeding itself, hybridization, cloning, inbred nurseries, until the final screening of your varieties in agronomy and variety testing. At each step, phenotyping tools bring useful information to enhance decision in breeding. Plant Ditech sensors stimulate different environments and help establish the profile of plant physiological responses. Dorian plant breeding software supports experiment monitoring and traceability and centralizes heterogeneous information for decision making. And Hiphen field phenotyping brings a new dimension to yield evaluation. And now, Keren Moshelian, CEO of Ditech, will say more on how their expertise contributes to the quality of genotype selection in the early breeding stages.
Let's start by talking of a key gap today in the breeding process, which is the phenotyping genotype by environment bottleneck. Many plants and gene candidates are economically made available, but the repeated selection process takes long time and effort, especially when we talk about environmental impacts, which are harder to control and measure. We are offering a high-throughput automated phenotyping system to make a significant improvement in this process and make the whole genotype to phenotype selection process much more efficient. With plant Ditech system, the experiments are performed in a controlled environment, and experiments can efficiently be made in order to save time by 1 to up to 3 years and increase the quality of selection towards the next phase of field trials. Our system, which is called the plant array system, is automatically performing indoor pot experiments. Greenhouse pot experiments are very effective when you want to isolate the noise from the soil and other reasons and get clear-cut results. The system performs automatically 3 steps. The first is automatically controlling soil and water stress conditions to provide a variety of environments to each and every plant in the array. Second step is measuring all the plants' response simultaneously and continuously with physiological and environmental parameters. Third step is analyzing in real time all plants, including statistical analysis like t-test and ANOVA, already at the time of the experiment to save time. These are the many traits that we are collecting from all the plants at once on a per plant basis. Transpiration on a momentarily basis, biomass gain on a daily basis, water use efficiency, roots influx on a momentarily basis, stomatal conductance, the same, light reflector sensors on a continuous basis, NDVI, PRI, IR, atmospheric sensing of different kinds, soil sensing of different kinds, and reservoir sensing. All these parameters and traits are being uploaded to an analytical software which is in the cloud. And there you can view your experiment and analyze the results from your office or home. By the way, thanks to that, all our clients actually have been able to continue and work regularly on their experiments and progress their research even during the lockdowns. The system works with many different plants in different growth stages, from vegetable and field crops up to even trees. Comparing plant array measured functional traits with field yield results demonstrated a very high correlation of 0.8 to 0.9 R-square. With a real-time cloud-based analytics, the data is gathered while the plants are growing, and knowledge is generated within days as plants are being measured and analyzed at the same time. In this video, you can see a 1-month trial at drought testing, and the plants, while they are growing, the data is being gathered and showed, demonstrated in a graphical view, and also analyzed by heat map and other even statistical graphs like ANOVA and t-test, like you see in this example, which has 7 different genotypes on the same graph. And this is showing you under water stress and the recovery. And you can see at each point the statistical analysis for each of the data point. The next slide is about another example of ranking the genotypes in the software by their function. Ranking performed by cumulative plant biomass, transpiration, stomatal conductance, and drought resistance traits, for example, as part of the traits that we are measuring. Another example is of early detection of biotic stresses. You can see here in this example that genotype C and D transpiration performance flattened due to a root disease, while A and B continued producing. By the RA or image, you could hardly spot it above surface even on the 35th day, where on the system it was demonstrated already from the 21st day onwards. A little bit about our company history. So our company's technology was developed at the Hebrew University, the Faculty of Agriculture in Israel, from experts in plant physiology and soil and water. It's a patented technology with over 25 academic articles already today using the system. The company is commercial since 2017, with already present in 8 different countries, some in Europe, North America, China, and Israel. Some of our distinguished customers in the university space is the #1 university, Wageningen University. In the food and breeding, it's one of the leading companies is Mars Wrigley for cocoa breeding. And for chemical and biostimulant screening, ICL is one of the global leaders, and we are proud of them being our customers. And there are, of course, many more customers. In summary, PlantArray is a high-throughput phenotyping system for fast and precise screening of plant functional vigor, productivity, and resilience. The key benefits are shortening the time to market of new products quite significantly. It's the quantitative selection and the definite results which you can trust towards the field testing. More product varieties that you can test in one season, in the same season, and the different environments which you can test in parallel. And focused field trials. When you arrive to the field trials, you know what to expect. You know also how to design the field trials in the right way. It is easy to extract data to any system, including larger breeding data systems, such as Dorian's data system, to help build the breeding knowledge base. Thank you for your attention. You're welcome to visit our website, YouTube channel, and LinkedIn pages. My email will be displayed at the end of the webinar, and I encourage you to raise questions in the chat. And now I hand it off back to Romain. Thank you, Romain.
Thank you, Keren. Now we can see clearly how physiological and environmental sensors bring valuable information to the plant breeder and can be analyzed in real time for faster and more efficient selection process. In the breeding pipeline, it can be integrated in the central database, upstream by transferring germplasm information to the phenotyping platform, and downstream by retrieving information on elite lines and physiological traits. Next, Lee West from Hiphen will describe how image analytics are transforming the way crop researchers are evaluating cultivar performances in the field.
Thanks, Roman. As Roman mentioned, I'm Lee West, and I'm the business development lead for Hiphen Agricultural Imaging Solutions. Before I started with Hiphen, I contributed to and managed a global agricultural product development team that designed and implemented product performance trials for more than 2 decades. So I was a customer persona for Hiphen, for Plant Ditech, for Dorian. If these tools had only been accessible then, I almost cry when I think how much richer and more useful our phenotyping data, our data sets would have been with these technologies. So after you set up your development pipeline and protocols in Dorian's R&D Experience Suite, and then you utilize the innovative Plant Ditech platform to help determine which SNPs and QTLs indicate which physiological responses you're interested in, the next step is testing the cultivar performance in the field. At Hiphen Agricultural Imaging Solutions, our mission is to bring image analysis tools to the agricultural research community and your field trial programs. We've built a platform that helps organizations effectively acquire research-grade images, innovatively analyze those images, and efficiently incorporate the images and data into product development pipelines. The challenges that we're trying to help researchers tackle is, how do your cultivars or products perform in the field? So how do we help researchers assess their cultivars and products? We have a wide range of traits on a wide range of crops that we can assess. These traits are all incorporated into the production grade analytical factory behind our Cloverfield platform, which I'll talk about shortly. So in 2020, we rolled out things like cercospora detection in sugar beets, and we supercharged our modules for plant counting, allowing us to deliver novel traits such as planting gaps and border effects. We have webinars on our website and LinkedIn page describing these in more detail. But today I'd like to briefly highlight 2 new additions to our catalog that we're excited about this year. The first is weed head detection and enumeration. So experimentation on wheat requires expensive manual measurements to monitor the yield components such as wheat head density after earing. If you've ever spent days in the field counting wheat heads, you know this is tedious work, and it's usually evaluated manually and on a restricted portion of your microplots. Basically, you're subsampling. So last year, the global wheat head dataset was compiled as a first collaborative answer to this global issue. 9 institutions from 7 countries have gathered their data and knowledge to tackle the wheat head density issue. With nearly 5,000 images and 200,000 labeled wheat heads, the global wheat head dataset is the largest annotated wheat head set ever assembled. We have been posting an entire short video series describing the data set and the challenge on our LinkedIn page. Above you can see an image taken by a drone. The arrow takes you to an image after automated processing. And then the table shows that there's a correlation between the manual counts and the drone estimate. With deep learning tools, this tool will get even better with each image set that is that's analyzed. The take-home message for our research clients and partners is that we now have wheat head counting as part of our production platform. Whether you have drones, phenomobiles, handheld units, we now can help you count wheat heads in an automated and consistent manner. One exciting extension of this project was that the convolutional neural network behind the model is robust enough that we've actually been able to extend it to barley also. The second trait that I would like to talk about here today, second innovation we're releasing this year, is plant singulation on sunflower. The ability to singulate individual plants allows for much more granularity on trait distribution within a plot. Rather than simply having an average F cover, we can now characterize the distribution of an attribute across a plot by plant. We start by identifying centroids for each plant at the beginning of the growing season, which allows us to partition plants and then calculate traits by plant. Of course, sunflowers are heliotropic and they move quite a bit. But through clever application of deep learning tools, we've been able to link each flower to a specific plant and the traits associated with that specific plant that grew that specific head. The other powerful tool we've added to our platform is head volume estimates. When linked to growth curves, this allows researchers to link early season growth to head size. So after collecting all these traits, our Cloverfield platform is where we put everything together. With Cloverfield, you can consolidate all of your image processing in one place. So you can easily upload images, turn those images into a wide range of trait assessments, visualize the data across your geographical footprint. You can zoom in and look at the details of your trials, quickly keying in on any of the traits across the trial and in any specific plot of interest, on any date and at any site. We can also analyze satellite images from low orbit satellites like the PlanetScope constellation, which at 3 meters spatial resolution and daily temporal resolution provide detailed dynamics of any crop. Then easily download the data and bring it into your product performance database like Dorian's R&D experience suites, which you'll hear Tristan talk about shortly. At Hiphen, we analyze images every day, from satellites to drones to phenomobiles and even smartphones. We would love to help you achieve your phenotyping ambitions. You can visit our website and LinkedIn page to learn more. Please type in any questions that you have to the chat and we will try to get that to them at the end of the webinar. Thanks for joining. Now back to Roman.
Thanks, Lee. It's great to see all the benefits of field image analysis for plant breeders. Now, what information can be integrated to the plant breeding software? This phenotyping platform requires information on the trial setup and on the materials, and it generates new traits data that can be transferred in real time to the central breeding database. And now, Tristan Dominique from Dorian will tell us more about how to integrate such phenotyping data to the plant breeding program and why it's worth it.
Hi again. First, I will say a few words on our company, Dorian. We are a software company specialized into digitalization of vegetal and agro R&D activities. We provide a software suite which aims to integrate all the R&D activities for a breeding program with a unified system. We work with agro-food, cooperatives, public institutes, and breeding companies. The flexibility of the tool we offer address breeding specificities of any type of crop: feed crops, flowers, forages, trees, and vegetables. We previously said that my colleagues of Ditech and Hiphen bring innovative phenotyping tools and methods which aim to accelerate the breeding decisions. In fact, these tools can benefit from an integrated database to guarantee fair data over the different activities and all along the breeding pipeline. These digital tools must ensure findability, accessibility, interoperability, and reusability of the information, and R&D experience fully responds to these standards. It reaches this objective by providing tools for the complete cycle of information management and at each stage of the breeding program. R&D experience proposes features for protocol definition and planning, such as structures for material description, capability to define the breeding goals and the breeding pipeline in accordance, the management of a seed bank and inventory of available material, or the decisions of resources allocated. The R&D experience gives also assistance into experiment monitoring with notably tools to support and track sowing, planting, agronomic operations, and harvesting, or with structures to track post-harvesting seed treatment. R&D experience offers also structures for heterogeneous data centralization like environment, pedigree, genetic, and phenotypic information, of course. And finally, it includes the decision-making tools and the reports for next stage planning like graphics and algorithms for descriptive statistics, for GBI, and for multifactorial analysis. To illustrate how the tools offered by Dorian can support breeding department with the completion of tools and expertise of my colleague, we can summarize like that. The R&D experience suite can accompany breeders in information management all along the product development pipeline by helping into germplasm description and the definition of improvement strategies per segment, for example, the project management and experiment monitoring features all along the breeding stages, notably to manage crosses, back crosses, DH, or any type of material manipulation. Of course, capabilities to track and secure historic information, notably during final screening or pre-commercial phases when it must go through multiple validation steps. And finally, with decisional tools which can help the breeders to visualize the targeted information with handy and friendly interfaces. R&D experience as a data warehouse for breeding information management benefit from any sources of new information which can require to support decision or which need to be historized or crossed with pedigree information. So in early stages, physiological and biological traits coming from plant Ditech ecosystems, or genetic information to characterize variability to support traits discovery and breeding decisions. In downstream stages, yield components for field performances generated by Hiphen tools, and environmental data captured from IoT sensors. And I would like to end my part by a concrete example on how a breeder can benefit from the R&D experience suite to manage breeding processes enriched by plant Ditech and Hiphen analytic tools. For example, biomass or transpiration index on individual plants in early stages of breeding, which can be combined with pedigree information. Like we can see on this video, interfaces tools of R&D experience enable to centralize such physiological traits into the breeding database. These physiological results can be combined with pedigree information to better characterize also the parental line. We can notably see through dynamic pedigree tree view all the genealogy of the most performing lines and clones. It can give a good ideas of new recombinations to get and the genetic gain. Other example for field phenotyping, the new index generated by Hiphen analysis of images can be centralized into our software suites thanks to open interfaces tools. They can be then combined with other agronomic traits for multiple factorial analysis and can be entered into the statistical tooltips to support screening and selection. We can see on this video different graphics profiles which help into visualizing this information. And the new traits like NDVI or LEI can be analyzed at a trial level to select best performing cultivars and move forward. I hope I brought you some responses on why a centralized database system such as R&D Experience can bring value in your breeding work. Some factors of response can be first by improving the sharing of information among activities, notably between lab and feed or between pre-breeding and product development. Then by securing the breeding knowledge, because the methods are described into the breeding management software, it guarantees uniformity of processes. And finally, by transforming data centralized into information from constant improvement. So it should make the breeding processes move forward by avoiding data copy, saving time to retrieve historic information, and by proposing to automate some tasks which can be repetitive at key operation stages. Thank you for making attention, and I will be pleased to respond questions if you have after the conclusion of Roman. Thank you very much.
Yeah, thank you, Tristan, for this overview on the benefits of the plant breeding software for breeders, notably to compare this smart phenotyping data with the genotype information and to automate all the tools for data capture and centralization and save time in the breeding decision making. And to conclude, high throughput phenotyping brings new traits to characterize the material and give more information to the plant breeder from the nursery screening stages to product performance evaluation. The main benefits are to get objective information without human interpretation, to bring more traits for breeding decisions, to integrate dynamicity within the breeding scheme. It brings tools and methods adapted to each breeding stage. And eventually it saves your precious time and enhances profitability. But most of all, high throughput phenotyping enhances research and increases the quality of your selection. And I'd like to end with this quote by Sébastien Chatre, research director at RAGT, who says, in variety selection, yield criteria is less important today than resistance to disease and climate change. Yes, these innovative technologies we have presented today enable you to consider new traits in your breeding decisions and make your R&D department ready for today and future challenges. Thank you very much for your attention, and see you soon for another great video. And our next webinar is on field trial qualification, and I hope to see you, many of you out there. Bye.
Thank you. Good
Thank
morning.
you.
Thank you.
Yeah.